Welcome to qnawire.
In this problem, a patient is resting on a bed, which we could view as this block resting on the inclined plane, and we want to figure out what the maximum angle of this inclined plane can be before the coefficient of static friction is not large enough to keep them at rest here. And so I've set up this force diagram here. We've got the friction force pushing this way because it's opposing the desired motion of the object. The normal force is normal to the surface. A force of gravity is pushing straight down. And then this angle here is theta. And so we can break that up into components. And I should also set my coordinate system. I'm going to let down the ramp be positive x and perpendicular to that be positive y. Now we want the case where the patient does not start sliding. And so that means that we're going to set the acceleration in the x direction equals 0. Because if the patient starts sliding in this direction, the acceleration is not 0 anymore. But if we do set it to 0, we're setting the constraint that the patient is not moving. And we also want to apply Newton's second law in the x direction, which says that the sum of the forces in the x direction is equal to mass times acceleration in the x direction. But we just set that equal to 0. And so the sum of the forces in the x direction must be equal to 0. There's only two forces in the x direction. The normal force is not. This component of gravity is not. But this component is. The mg sine theta is. And then also the friction force is. Since down the ramp is positive x, I'm going to let the mg sine theta be positive because it's pointing down the ramp. And then the friction force is pointing up the ramp, so I'm going to make that negative. I know that these two have to add to be 0. Now the friction force is equal to the static coefficient times the normal force. Really, since we're using the static coefficient, the friction force can be less than or equal to, but we want the limiting case, so I'm just going to set it equal to this. And the normal force is the same as the mg cosine theta here. Just like that. Now you can reason through that because the person on the bed is not going to accelerate in the y direction, meaning the sum of the forces in the y direction have to be equal to 0 as well. And there's only two forces in the y direction, the normal force and this force. And so that directly implies that the normal force is equal to mg cosine theta, like that. And so that lets us write down the friction force. And so just continuing on my Newton's second law in the x direction, I'm going to subtract mu s times n, but we found that n was mg cosine theta, and then this is all equal to 0. Now I can divide both sides by mg, and so those go away. I'm going to move this negative term over, and I'm going to divide by cosine. Since sine over cosine is tangent, that leads to tangent of theta is equal to mu s. And ultimately, we're trying to solve for this theta. And so theta is equal to the inverse tangent of mu s. Plugging in, mu s is equal to 1.2. This gives theta is equal to 50.19 degrees. That's the final answer.